Okay, in this video we're going to continue our discussion on conic sections. Hopefully by now you have learned about parabolas, ellipses, and hyperbolas. So what we're going to do in this video is we're going to take it up just a notch, and we're going to start shifting them around so that they're not all centered at the origin. So it's kind of combining function transformations in terms of translating a function to different locations on the coordinate plane, combining that with graphing conics. So what you're going to see is simply just a hyperbola or an ellipse or a parabola, but what you're going to see is that it's not just going to be x squared and y squared. There's going to be some sort of transformation to x or to y. So this one is kind of already done for us. We just have to look at the transformation and apply that when we graph it. The plus 1 with the x is simply just moving it to the left h units. The minus 2 with the y is moving it up 2 units. So kind of do the opposite of what you see with x and y, and that's going to be the new focal point, like the new location of the center of your ellipse or the hyperbola or whatever it is you're graphing. So I know that because of my transformation of plus 1 and minus 2 here, that the center of this ellipse is going to happen at -1, 2. Alright, so just do the opposite of those values to get that center point. I'm actually going to go ahead and graph. I think a lot of this information is clearer to see if you actually graph it as you go. So the center is at -1, 2, and I'm going to put a point there at -1, 2. So remember what we did with an ellipse is we looked at the numbers underneath, and we did the stretch on that axis as the square root of those numbers. So what I'm going to do at this point is I'm going to go along the x-axis 2 units each direction to the square root of 4. Now, when I say x-axis, I mean from this reference point that is the center. So we're no longer centered at the origin. We're now centered at this point, -1, 2. So I'm going to go 2 units to the left and 2 units to the right of that center point. And then on y, it's 3 units because we have 9 underneath, so I'm going to stretch it 3 units vertically from that point. Okay, and if I do that, I now have the ellipse that is centered at -1, 2. That's stretched 2 units horizontally and 3 units vertically. Now after doing that, now I can kind of come up with those other pieces of information. So the vertices. Well, so normally the vertices are the coordinates where it's stretched the most. So you would say, well, it's stretched the most in y, and so I went out 3 in each direction vertically, and so we would say 0, plus and minus 3. Well, I'm going to do that 0, plus and minus 3 as a transformation to the center point. So what I'm going to do is I'm going to take my -1, 2, and then I'm going to add to that 0, plus or minus 3. And then I can look at that as either -1, 2 plus and minus 3, or if you prefer, you could write both of those out, right? So that's going to be -1, 5 and -1, -1. And those are the coordinates of the vertices. Well, if you just look at the way that it's stretched most, which is vertically here, and you have that actually graphed, you should be able to tell me that those happen at -1, 5 and at -1, -1, like you see them in the graph. But that's how we get that. We take the center and then do that plus and minus 3 in the y to that. And I don't change the x, it stays -1. If the bigger stretch was with x, then I would adjust the x coordinate of my my center instead of my y coordinate. Okay. And then the foci. So the foci, we use the equation c squared equals a squared minus b squared. So remember, look at the numbers on bottom and subtract them. So we're going to get c squared equals 9 minus 4. We're going to do biggest minus smallest every time there. So c squared equals 5, and then we take the square root, and we get c to equal plus and minus the square root of 5. Now again, that happens along the major axis, so that is a y-coordinate adjustment to the center. So to get my coordinates of my foci, I'm going to take the center and I'm going to adjust the y-coordinate using that c value. And so my foci happen at -1, 2 plus and minus the square root of 5. Again, that would be an x-coordinate adjustment if the bigger stretch was with x. Okay, sometimes our equation is not going to be already in this nice standard form. So we're going to have to do some things to get it there. And a lot of times that's going to involve the process of completing the square. So if you're not familiar with that, we're going to do a couple examples here where we're going to complete the square to get our formula the way that we want it to look. Okay, so this next one is a parabola. And so what I'm going to do with a parabola, remember you want your equation to be x squared equals 4py or y squared equals 4px. Now I know this one is going to be x squared because my only squared variable is x squared here. What I need to do is be able to see my transformations. So I need to complete the square on the left side of my equation here. And so remember that process of completing the square is to take this b value, divide it by 2, and square it, and then we're going to add that in, and we're going to have to do that to both sides of the equation. So -4 divided by 2 is -2. If we square that, we get +4. That's going to go on both sides of the equation here. What that allows you to do is it allows you to take this left side and factor that as the same thing twice, right? So I'm going to get x, that's the whole point of completing the square, I'm going to get x minus 2 twice there. X minus 2 squared equals, now on this side, this -8 plus 4, that's going to be -24. And then what I'm going to do is I'm going to factor out the number that's in front of y there, which is 8. I'm going to factor that out of both of those terms. So that's going to be 8 times y minus 3, right? If I also factor an 8 out of that, I would get 3. Now our equation is actually in the form that we want. What we're going to see from this is the transformation that has occurred to both x and y. So the vertex of our parabola is no longer at 0, 0. It is apply the transformations at 2, 3. So if I go to 2, 3 and I plot that point, that's going to be the vertex of our parabola. And then I need to find the value of p, right? So we always, when we looked at parabolas, we said, well, if we can find the value of p, then we can figure out where the focus is, where the directrix is, and things like that. So the way that we're going to do that is we take the number that is in front of the non-squared variable, so that whatever that number is that we factored out, we're going to set 4p equal to that number. So that's going to tell us that p is 2. Now, because it's x squared, I know that my parabola is vertical in nature, and because it is a positive p-value, that means it is going to open upward. So the focus was normally at the coordinate of 0, p, right? That's what we said for the focus, or p, 0 if it was sideways. But it's not going to be at 0, p. It's going to be use your vertex and then go 0, p from there. So the focus of our parabola is going to be at 2, 5. The way I'm going to get that is I'm going to take this p value and I'm going to add it to that y coordinate there. So at 2, 5, I have my focus. Now, the directrix was normally y equals -p, which means go that same direction the opposite way. So I'm going to go down 2 in this case. And I'm going to draw, remember the directrix is that horizontal line. So the horizontal line is actually going to occur at y equals 1. That's our directrix. Because it is this value, that p value, down from the vertex. So I'm going to go down 2. So I went up 2 for my focus, I go down 2 for my directrix, and I have a parabola. Okay, here's our focus, and here's our directives. Once you get that form that you want, plot your vertex, find the value of P, and then just do that adjustment to the vertex. And usually if you do that and you think about the graph first, then you can get this information a lot more quickly. Okay, next up, we're looking at a hyperbola, and this one is not in the form that we want, so it's going to take a little bit of work to get there. So what we're going to do here is we are going to complete the square both in x and in y to get it to the form we want, and then we're going to be able to find the information in graph. So here's how you're going to do that. You are going to group your x's and group your y's, and you're going to factor out the coefficient in front of your squared term for both of those. So I'm going to do 9 times x squared minus 8x, save some space, and then we'll do the same thing for y. So minus 16 y squared plus 2y, and then equals 16. I'm going to complete the square with both x and y. So if I take negative 8 and I divide by 2 and square that, I'm going to get plus 16 here. And with the y, if I take 2, I divide that by 2 and square it, I'm going to get 1. Now I have to also adjust the right side of my equation to account for both of those. So what I really put here was 9 times 16, right? There's a 9 out front of this 16 that I put there. So I have to also add over here 9 times 16. And then when I put that 1, what I really put was negative 16 times 1. So I'm also going to have to do minus 16 times 1. I need to have both of those things added to that side. If you then factor, we've got 9 times x minus 4 squared minus 16 times y plus 1 squared equals, now this side, if I add all of this together, the minus 16 and plus 16 cancel out. I get 9 times 16, which is 144. Then at that point, what I want to do is make it equal to 1. So I divide everything by 144. And if I divide these things by 144, I can reduce the numbers out front with 144. This is going to be 1. So I'm going to get x minus 4 squared over 16 minus y plus 1 squared over 9 equals 1. And that is the equation of our hyperbola. Once I have that information, I'm going to go ahead and figure out where the center. Now, the center is not something that we actually is actually part of our graph. It just helps us to see where we shifted it to. So the center is at 4, negative 1. Remember, do the opposites here. So 4, negative 1. I'm going to go to 4, negative 1, and I'm going to put a point there. And then remember, the next thing we did with the hyperbola is we drew that central box. So the central box is going to happen. We're going to go 4 out to the left and right from there. So go 4 and 1, 2, 3, 4. And then I'm going to go 3 vertically. 1, 2, 3. And 1, 2, 3. And I'm going to go ahead and draw that central box. And so that's what our central box is going to look like. Then what I'm going to do is draw the asymptotes. So the asymptotes will go through the corners of the box here. So we're going to go up through it this way. Let me try to get that a little bit better here. Up through it this way. And then also down this way. Try that again as well. Okay. Now remember, what determined the orientation of the hyperbola was which one was written as the positive value. So in this case, the x is the positive value, right? And then I have minus and then the y. So that means that the orientation is horizontal. So our actual hyperbola will look something like this. Now, I've graphed it. Now I'm going to go through and figure out what all this information is. Okay, so the vertices. Well, you could just look at the actual coordinate points that you have for your vertices. You could do your adjustments from the center. If we just look at the actual coordinates, we can see that those happen at coordinates of 0, -1, and at 8, -1. And that's just going out plus and minus 4, because of the 16, plus and minus 4 to the x coordinate of our center, 4, -1. The foci, so I'm going to do c squared equals a squared plus b squared. So in this case, I've got 16 plus 9, so c squared equals 25. So c will be plus and minus 5. Now again, that's going to happen to the x coordinate of those. So I'm going to go plus and minus 5 from the 4, which would give us -1, -1, and 9, -1. And you would see that it would just be 1 unit in from where we have those points of our vertices. And then the asymptotes. The easy way to do the asymptotes again was to count your rise over run. So we went up 3 and over 4. So our slope is 3 over 4 and -3 over 4. But we can't just say y equals plus and minus 3 over 4x. We have to adjust for the transformation to where our center is at. So instead of just saying x and y, we're actually just going to use these phrases that we have on top of our equation here. So we're going to write it in point slope form. So it's going to be y plus 1 is equal to plus and minus 3 over 4, and then times x minus 1. That would be the equation of the asymptotes. Okay, so that's kind of a tough question. I assume that one example of those is not going to necessarily be sufficient in terms of understanding all of that. But keep practicing that, and hopefully you get those subtle aspects of being able to complete the square on both, and then understanding how that changes these values for your vertices, foci, and so forth. The last part of this is pretty simple, and it is simply just if I see an equation written in this general equation form, can I determine what kind of conic section I have? And all you need to look for are the squared variables. Okay, look for the squared variables, and this is what you're going to say. It's a parabola if a or c is 0, which means if I only have one squared variable, it's a parabola. So I know number 2 is a parabola because I only have one squared variable, and that is that x squared out front. All the other ones have more than one squared variable, so I know it's not a parabola. It's an ellipse if a and c have the same sign. So if a and c are both positive or both negative, it is an ellipse. However, more specifically, it's a circle if a and c are the same coefficient, because that would involve us going out for our ellipse. It would be a stretch vertically and horizontally the same amount. So if you look at number 1, both the x squared and y squared are positive, but they're different numbers. Therefore, that's an ellipse. On number 4, the x squared and the y squared are both positive values, and the coefficient is the same. It's 1 for both of those. So this is actually a circle here. And then it's a hyperbola if a and c have opposite signs. So if they are one positive, one negative, that is going to be a hyperbola. So just checking those squared variables will help you determine, before you even start with anything, what kind of conic section you have.